Here in this video, we will find how to plot a graph of linear and nonlinear equation with two variables. We know that there are two kinds of variable. The first one is a dependent variable and the second one is an independent variable. So say y is a dependent variable and x is an independent variable, and we call it like this because we can relate y by the relation y is equal to f of x. So we can call it to be y is a function of x. Now why we call it to be a function of x? Because we can see that for every value of x, we will have a value of y. So that is why y is called to be a dependent variable and x is called to be an independent variable. Now this functional equation can have different form, like y can relate with x by the equation y is equal to 2x, say, or it can relate by y is equal to say 5x plus 3. So we can generalize this kind of equation by the first equation we can generalize it in the form of y is equal to mx, and this equation we can generalize it like in the form of y is equal to mx plus c. Also y can relate with any power of x actually. So y can be y is equal to 2x square plus 3x plus 4 say. So this kind we can generalize this kind equation by y is equal to ax square plus bx plus c. So in both of these two equations we can find that this m and a or b or and c are nothing but constant. So it can take any value, like in the previous equation y is equal to mx. So we can see that here m is equal to 2, and on the second equation we can see that the m is equal to 5. So this is how the constant part can take any value. But the difference between these two equations is in this kind of equation y is directly proportional to the x. So it is directly proportional to the first power of x, and on the second equation we can find that y is directly proportional to x square. So actually y can be any power, or y can be proportional to any power of x. Now if we want to plot this kind of equation into a graph paper, we can do so by, suppose we want to plot y is equal to 2x in a graph paper. So we can take a normal millimeter graph for it. Suppose this one is our graph. So we can consider two different axes along the two sides of the graph. So this axis is ox and this axis is oy. Suppose we want to represent variable x along the ox axis and y along oy axis. Then we have an equation y is equal to 2x. Then at first we need to determine the different values of y for different values of x actually. So we can tabulate the values of x and y, like when x is equal to 0, we can see that by the equation y is equal to 0. When x is equal to 1, y is equal to 2. When x is equal to 2, y is equal to 4. When x is equal to 3, y is equal to 6. When x is equal to 4, y is equal to 8. When x is equal to 5, y is equal to 10. So these are different values of x with these are different values of y actually, which we get by replacing different values of x. So that is why y is a dependent variable. Now if we plot these values on the graph, then we will see that for x is equal to 1, we are considering every division of graph paper to be an unit. So for x is equal to 1, we will get y is equal to 2. So this is our point. So for x is equal to 2, y is equal to 4. So this is our point. When x is equal to 3, y is equal to 6. This is our point. When x is equal to say 4, y is equal to 8. So this is our point. So when x is equal to 5, y is equal to 10. So this is our point. So actually we will start our graph, we will find the initial point of the graph from the origin, because this is the value when x is equal to 0, y is equal to 0. So if we connect this point with a line, then we will see that this will be a straight line. So that is why y is equal to 2x, or we can say it in a generalized form, y is equal to mx is represents a straight line, and we can say it to be a linear equation. Linear equation. Similarly, we can plot the graph for function y is equal to 5x plus 3, say. This was our second equation. So for that we need a graph paper. So suppose this is our graph paper. Again we have to represent two axes on the two different sides of graph paper. So this is our y-axis. Say this one is our y-axis and this one is our x-axis. So this is OX and this is OY. Along x-axis we represent independent variable x, and along y-axis we represent independent variable y. So from we need to first again we need to tabulate the different values of y for values of x actually. So x and y. So when x is equal to 0, we will have y is equal to 3. When x is equal to 1, we will have y is equal to 8. When x is equal to 2, we will have y is equal to 13. When x is equal to 3, we will have y is equal to 18. When x is equal to 4, we will have y is equal to 23. When x is equal to 5, we will have y is equal to 28, and so on. This is how x and y, this is how y change when x takes different values actually. So for x is equal to 0, we will have y is equal to, so when x is equal to 0, we will have y is equal to 3. So this is 1, 2 and 3. So this will be our initial point. Similarly, when x is equal to 1, we will have y is equal to 8. So this will be our second point. Similarly, when x is equal to 2, y is equal to 13. So this will be our third point. So when x is equal to 3, y is equal to 18 and 18. So this will be our point. Similarly, when x is equal to 4, we will have 23 and 23. This will be our point. And when x is equal to 5, y is equal to 28. So this will be our point. So this is how the graph will look like. So if we connect this point, we will again find a straight line, but this time the straight line is not going through the origin. So this is the initial part, this is the constant part or the initial part, which actually represent the intercept of the straight line on the y-axis actually. So this part 3, or if we generalize this equation like y is equal to mx plus c, so this c is the intercept on y-axis. So c is the intercept on y-axis. So this is how we can plot graph, but this graph is also a straight line. This is also a straight line. So equation y is equal to mx plus c, also an equation for straight line, and it is also a linear equation because y and x varies linearly with each other. But if we plot the graph, say if we want to plot the graph for the equation y is equal to 2x squared plus 3x plus 4. So our third equation was y is equal to 2x squared plus 3x plus 4, and now we will plot the graph of it. So we need a graph paper for it. So this is a normal millimeter graph. So this one is a normal millimeter graph. Again, we need two axes. So this is our reference frame. Suppose this one is x this is O, this is Y. So OXY is our reference frame, and we have a function y is equal to 2x square plus y is equal to 2x square plus 3x plus 4. So in this case, we also need different values of y for different values. So we will find different values of y for different values of x actually. So when x is equal to 0, we will find y is equal to 4. Similarly, when x is equal to 1, we will find it will be equal to 2 plus 3 plus 4. So it will be 5 plus 4. So y is equal to 9. When x is equal to 2, we will find it will be 8 plus 6 plus 4. So it will be y is equal to 18. Similarly, when x is equal to 3, we will find y is equal to 31. In this way, the graph will continue. So when we will plot this graph on a graph paper, this functions on a graph paper actually, so x is equal to 0, we will have y is equal to 4. So this will be our point. When x is equal to 1, we will have 9. So this is our point. When x is equal to 2, we will have y is equal to 18. So this will be our point. When x is equal to say 3, then we will have y is equal to 31. We cannot represent this point on a graph paper because this will be out of our graph paper. So we cannot represent this point on this graph paper because this point will be out of the graph paper. Now if we connect all this point on the graph paper, then we will find that this graph will look like this graph will continue like this. So this is not a straight line, instead this takes a shape of parabola. So actually it is not a straight line, and we call it to be a, that is why we call it to be a non-linear equation. So equation which is related to any other power of x other than 1, we will call it to be y is equal to 2x square. Here our equation was y is equal to 2x square plus 3x plus 4, or in generalized form we can write it to be y is equal to ax square plus bx plus c. So this kind of equation is a non-linear equation. So graph for this kind of equation will be parabolic in nature. Now we need to find what is this m. Now say y is equal to mx is our equation. Suppose when the graph is passing through the origin, then actually we will have this kind of equation, y is equal to mx. Then by solving this equation, we can say that m is equal to y by x. So if we know the value of x and y, then we can find the value of m actually. And this can be done by, suppose this is our last point, so if we draw a perpendicular from here, then this will represent y coordinate of this point. Similarly, if we draw another perpendicular to the y axis, then this intercept will represent x coordinate. So this is the x coordinate of this point, and this is the y coordinate of this point. So we will take intercept between any 2 points of the graph. Suppose we want to find the value of m, and for that we just need to draw what is the change of x coordinate of this point and x and y coordinate of this point. And we can do that by, if we denote the change of x and y coordinate of this point with respect to say this point, then the change in x and y coordinate of these 2 points can be represented by, this point is say delta y and this is say delta x. Now delta actually represents change, that is why we can write m to be change in y axis, that is delta y, with respect to the change in x axis, that is x. And in this case we can see that this point, coordinate of this point was 1.2, and coordinate of this point is is 5.10. So change of y-axis is from 2 to 10, so that is 8, and change of x-axis, that is 1 to 5, so that is 4. So that is why we will find m to be 1, and that is what we are started with. So m to be 1. Similarly, in this equation also we can find m. Suppose in this equation we try to find m, so this is also a linear equation. Suppose we find what is the change of y and x coordinate of this point with respect to this point, then actually this is the change in y-axis, so delta y, and this is the change in x-axis, that is delta x. Now the coordinate of this point will be 1.8, and coordinate of this point is 4.23. So if we denote the change, if we want to find m, then it is delta y divided by delta x. Now delta y is 23 minus 8, that is 15, and delta x is 1 minus 4 minus 1, that is 3. So obviously we will find it to be 5. This is what our equation was. So y is equal to 5x plus 3. So we can find that the value of m, it can be represented by denoting the change in y-axis, by denoting the change in x-axis. So that is why it is known as slope, because here we actually finding the slope. Here by this equation we actually denotes the slope, that is change in y with change in x. And when we are considering this triangle, say during the determination of slope we are considering this triangle, so this was our triangle. So if this angle is theta, then we can find that this is a right angle triangle. So this will be our perpendicular, and this will be our base, and this will be our hypotenuse. So as because we want to find the change of perpendicular with respect to base, so we can write this slope m, change in perpendicular with respect to change in base, and that is why we can say it to be tan theta. So we can say this m is equal to slope is equal to tan theta. And as we know, when theta is very small, then tan theta is nearly equals to theta. So that is why we can write m is equal to theta is equal to slope. But in this kind of graph, for a non-linear equation, we cannot find actually m, because in this case m is actually changing at every position. Suppose this is our parabolic graph, and we cannot have a particular value of the slope, because if we want to find the slope at this point and this point and this point, so slope between these 2 points different than the slope between these 2 points. Here the value of the slope, say theta 1, then it will be the value of the slope theta 2. So we cannot have a particular value of theta. But however, if we want to find the instantaneous values of a slope at a particular point, then we can do that by considering tangent at that point. Suppose we want to find the slope at this particular point, say we want to find the slope at point A, then we just need to draw a tangent there, and then we have to determine what is the slope of this tangent in order to find the slope at this point. Now this is the instantaneous values of the slope at this point with respect to x and y axis. Suppose this is the value of x axis at the point A, where xi, that means this is the coordinate of point x coordinate of the point A, and if this is the y coordinate of the point A, then xi comma yi is the coordinate of A, then slope at the point A will be the instantaneous value of slope. But on the first kind of situation, we can find that as because we are considering y is a linear function of x, that is why y is directly that means y is directly proportional to x. So the constant of proportionality there will have a constant value, and we will know that that constant value and that constant value is nothing but the slope of the graph.